Hello everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at MLR Institute of Technology. In previous sessions, we have seen about Banker's algorithm and deadlock characterization and what is about page table and paging. So in this session, we are going to see about page replacement algorithms. So let us see the overview of this presentation. So overview of this presentation, we are going to see about page replacement algorithms, and this is classified into three types. What are they? FIFO, LRU and optimal. FIFO, LRU and optimal. We are going to discuss about thrashing. So first let us start our page replacement algorithms. So in this operating system that uses paging for memory management. So paging is used for memory management. A page replacement algorithm is needed to decide which page needs to be replaced when a new page comes in. So first of all, what it will decide when the memory of the CPU is full and we cannot insert any page into that. So what it is going to choose, so whatever the page is which is required, so the page should be replaced by using three algorithms. What are they? FIFO, optimal, LRU. So which page should be replaced when the new page arrives? So based on this algorithm, the page will be chosen by this algorithm. So next, page replacement becomes necessary when a page fault occurs and there is no page frame in memory. So page frames, what do you mean by page fault and what do you mean by page frame? So in our problem, they gives consider three frames. So I am taking three frames. So F1, F2 and F3. In these three frames, these are three frames. What are they? F1, F2, F3. So in these three frames, suppose I am inserting 7 in first frame, again 7, 0 in second frame, again 7, 0 and 3 in third frame. So now these are the numbers 7, 0, 3, 2, 1. So these are when the page is found, it is hit. So when the page is found, it is hit. When the page is not available, it is fault. So page fault is indicated as star and hit is indicated as right tick. So this is page fault. So now this is not present, it is page fault, page fault, page fault. So now next number is 2. So which I have to insert, which page I have to remove or replace. So we are not using any algorithm. So I am considering as FIFO. So FIFO is nothing but first in, first out. So I am replacing 7 with 3. So 3 is already present. So 7, 0, 3, it is hit. So when it is present, we cannot remove any page. Why? Because it is present means the page is hit. It is not present means the page is fault. So next number is 2. So 702. Now which page I have to replace now? So I am applying first in, first out. So nothing but FIFO algorithm I am using. So I am replacing 7 with 2. So 2, 0, 3. This is also a page fault. So which is present is page hit and which is not present is page fault. That is what about this algorithm. However, another page fault would arise if the replaced page is referenced again. So if the page fault arises, here the page fault is occurring. So the page cannot be replaced. So it is going to reference again. Why? Because if again 2, 2 is present in our given problem, so the page is again referring the same number. That is what replacing the page with again with same number. That is what referencing again. Next, hence it is important to replace a page that it is not likely to be referenced in the immediate future. So it cannot be, the page cannot be likely to be referenced in the future. It cannot be immediately, cannot change. Why? Because it may be changed in the future. Immediately it cannot change. If no page frame is free, the virtual memory manager performs a page replacement operation to replace one page's existing in memory with page whose reference caused the page fault. So actually I have said when the memory is full, the page replacement operation is based on page replacement algorithm. So based on that algorithm only we can replace or reference a new page which is causing the page fault. That is about this point. It is performed as follows. The virtual memory manager uses a page replacement algorithm to select one of the pages currently in the memory for replacement. So suppose here the memory is full. Then which page should be replaced? All the memory is full and no frame is free. So we need to take one more frames and consider the another pages to insert. So next number is what here? 1. So which page should be replaced? I am using FIFO. So replace 2. 2, 1, 3. So it is also a page fault. So based on the algorithm which you have chosen for the replacement of the page, then only you can change the each reference frame. That is how the page fault occurs and how you are going to replace each page with each algorithm. Accesses the page table entry for the selected to mark it is not present. So which the page which is not present, we are marking as asterisk. When the page is present, we are marking as tick. So that is what the page is not present in memory. And initiate page out operation for if it is modified bit for its page table entry indicates that it is a dirty page. A bit of the page table entry indicates that is a dirty page, means the page, if the page cannot be modified, then the table or page table cannot entry and it is considered as dirty page. That is what about this point. So next, what is page fault? Page fault happens when a running program accesses a memory page that is mapped into the virtual address space but not loaded in physical memory. Page fault is nothing but while we are running a program, the memory which is mapped into the virtual address space but not loaded into the physical memory. Why? Because when the page is present, it is hit. When the page is not present, it is page fault. Since actual physical memory is much smaller than virtual memory, page faults happen. So whenever the actual physical memory is smaller than the virtual memory, whatever the chosen pages which is less than or smaller than the virtual memory, then here the page faults happen. In case of page fault, operating system might have to replace one of the existing page with newly page needed. So already which is existing, I want to insert another page. So we need to replace with the new page. Different page replacement algorithms suggest different ways to decide which page to replace. So we are using 3 different page replacement algorithms. What are they? First in, first out, and least recently used, and optimal. These are the 3 page replacement algorithms we are used to decide to replace the pages in whatever the suggestion made by the algorithms. The target for all algorithms is to reduce the number of page faults. So nothing but we need to reduce the page faults and to get the page replacement algorithms get success. So these are the 3 algorithms we are going to see now. So page fault ratio is, the formula for page fault ratio is number of page faults by total number of reference string. This is what about page fault ratio, and we need to calculate hit ratio also. Hit ratio is equals to number of hits by total number of reference string. So reference string is nothing but whatever the given numbers that we need to calculate. So this is what page fault ratio and hit ratio. So let us see our first FIFO, first in first out algorithm. So first in first out algorithm, this is the simplest page replacement algorithm. This is very simple and easy to implement the algorithm. In this algorithm, the operating system keeps track of all the pages in memory in a queue. The pages should be kept in queue format. The oldest page is in front of the queue. When a page needs to be replaced, page in the front queue is selected for removal. So the page which comes first should be removed first. So here they are saying when a page needs to be replaced, page in front of the queue, it is selected for removal. So it is used for selection of removal. So let us see one example problem how we are going to check the page faults and hits. So consider page reference string 1303563 with 3 page frames. Find the number of page faults. So we need to take 3 frames and insert the numbers, and we need to replace the each page into the 3 frames. So let us take the 3 frames. So F1, F2 and F3. So now the page frames is empty. So what is our first number is 1. So 1. Here what is our page replacement algorithm? Page replacement algorithm is nothing but first in first out. So the number which comes first, we need to insert it first. So first I am taking 1 and inserting in frame 1. So 1. So as it is not present, we need to indicate this is a page fault. Everyone clear? Next 1 after next number is 3. So already in frame 1 is present, and next 3 I am inserting in frame 2. So this is also a page fault. Next 0. So already in frame 1 is there, in frame 2 3 is there, and now 0 I am going to insert in frame 3. So this is also a page fault. So next 3 is present in our frame or not? Yes. So it is page hit. So 1 3 0. So our page is having 3 number in our frame. So that's why it is hit. Next 5. So 5 is not present. So now our frames are full. Which page I have to replace? So as we are using in first in first out algorithm, the page which has entered first, that is used for the removal first. So I need to remove the first page and insert 5 in that. So 5 3 0. So this is also a page fault. Next 6 is not present. So which page I have to remove? Next page should be 3. Why? Because 3 is entered the next. So 3 should be removed. So 5 6 0. This is also a page fault. So next last number is what? 3. So 3 is also not present. So which page I have to remove? 0. So 5 6 3. This is also a page fault. So these are the pages how we are going to insert and delete in first out algorithm. They also told find the number of page faults. So what are the number of page faults in our problem? So 1 2 3 4 5 6. So there are total 6 number of page faults in our first out algorithm. So everyone understood about first in first out page replacement algorithm. Next we are going to see about optimal page replacement algorithm. In this algorithm, page replace which should not be used for the longest duration of time in the future. So it may be used in the next, but it may not be used in the future. So whatever the pages which we are using for the longest time, and it should be in the future. It should not be in the future. So consider the page references. These are the numbers, and we need to take 4 frames. So in the previous in first out we have taken 3 frames. In this they are asking with 4 frames. So let us take 4 frames and start our page faults. So frame 1 F1, F2, F3 and F4. So first, what is our page replacement algorithm? It is nothing but optimal page replacement algorithm. In this we are going to see the pages which should be replaced would not be there for the longest duration in future. So first frame, what is the first page we are inserting? 7. 7 is inserted in frame 1. So it is also a page fault. Next 0, 7, 0. So it is also a page fault. Next, which number? 701. This is also a page fault. Next, which number? 2. 7012. This is also a page fault. So next, which is arriving? 0. So 0 is already present, so it is hit. 7012. So the page is present, so it is hit. So next, which is arriving? 3. So as it is optimal page replacement algorithm, so which number I have to delete or remove from the frame? So 7 is not there. It is not using for further in future. So 0 is arriving and 2 is arriving and 1 is not there. So 7 and 1. So as 7 and 1 are present, so which one you want to remove? So in this case, we need to apply first in first out. Why? Because 7 is not arriving for future and 1 is also not arriving future. So I am applying FIFO to remove this 7. So 7 is replacing with 3. So 3, 0, 1, 2. So this is also a page fault. Next is 0. So 0 is present. 0, 3, 0, 1, 2. So it is page hit. Next 4. So for adding the 4 into the frame, which page I have to remove? So 3 is arriving next, 0 is arriving in next, 2 is arriving in next. So 1 is not at all used in the future. So I am removing 1. So 3, 0, 4, 2. So this is also a page fault. Next, which number is coming? 2. So 2 is present. So if the page is present, we need it is a hit. So 3, 0, 4, 2. It is hit. So next, which page is coming? 3. So 3 is present again. 3, 0, 4, 2. It is also a hit. Next, which is page arriving? 0. 0 is again present. So it is hit. 3, 0, 4, 2. It is also a hit. Next, which page is arriving? 0 is complete, again 3. So 3 is arriving, so already it is present. So 3, 0, 4, 2. It is also a hit. So the page is present, so I am taking as hit. So next arriving 3 completed. Next is 2. So 2 is present. 3, 0, 4, 2. So it is also a hit. Next last which is arriving? Again 3. So 3. So 3 is present, so it is a hit. 3, 0, 4, 2. So we need to calculate the number of page faults. How many number of page faults found in our problem? Number of page faults equals to 1, 2, 3, 4, 5, 6. So there are 6 page faults in the given reference ring for the optimal page replacement algorithm. So the page which is not available or not used for the longest duration in the future, so we need to replace it with the replacement of using this optimal algorithm. So next, least recently used page replacement algorithm. In this algorithm, page will be replaced which is least recently used. So the page which is least recently used should be removed. So consider the following reference ring and with the 4 frames calculate the number of page faults. So as we have seen in the optimal page replacement algorithm, we have seen with 4 frames, and here also we are going to see with the 4 frames. So consider 4 frames F1, F2, F3 and F4. So these are the 4 frames we need to take. So first, which page is arriving? 7. So 7 I am inserting in frame 1. So it is also a page fault. Next 0 is arriving. 0 I am inserting in frame 2. F7, 0. This is also a page fault. Next 1 is arriving. I am inserting in frame 3. 7, 0, 1. And this is also a page fault. Next 2 is arriving. 7, 0, 1, 2. This is also a page fault. Next 0. So 0 is present. So it is a hit. So 7, 0. This is here. So 7, 0, 1, 2. So it is a hit. Next 3 is not present. So now which page I have to remove from our frame? So 7, which is least recently used, 0 is also used, 1 is used, 2 is used. So we need to calculate from the left. So 0 is there, 2 is there, 1 is there. So 7 should be replaced. Why? Because it is not used, it is least recently used. So which page I have to insert? 3. So 3, 0, 1, 2. So this is also a page fault. Next 0 is arriving. So 0 is present. So 3, 0, 1, 2. It is hit. So next we need to insert 4. So 4, which page I have to remove? Again check from left. So 0 is there, 3 is there, 2 is there, 1 somewhere it is there. So 1 should be removed. So 3, 0, 4, 2. It is also a page fault. Next 2 is present. So 3, 0, 4, 2. It is hit. Next after 2, 3 is arriving again. So 3 is present. 3, 0, 4, 2. 4, 2. It is also hit. So next again 0. 0 is present. 3, 0, 4, 2. It is also a hit. Next 3. Again 3 is present. 3, 0, 4, 2. It is also a hit. Again next after 3 again we are having 2. So 3, 0, 4, 2. It is also a hit. Again next 3 is there last. So it is also present. 3, 0, 4, 2. So it is also hit. So we need to calculate number of page faults. So number of page faults equals to 1, 2, 3, 4, 5, 6. So 6 is our number of page faults for this least recently used page replacement algorithm. So in FIFO we are removing the page which comes first. We are going to remove that first. In optimal we are using the page which is not used in future, that should be removed, and in LRU we are going to remove the page which is least recently used. We are replacing with the new page. These are the 3 page replacement algorithms. Next let us see about thrashing. Thrashing is a condition or a situation when the system is spending a major portion of its time servicing the page faults, but the actual processing is done which is very negligible. So thrashing is nothing but it is a situation where the system is having a major portion of its time servicing with the page faults. So until now we have seen about page faults, but the actual processing does is very negligible. The causes of this thrashing is high degree of multi-programming, lack of frames, and page replacement policy. In high degree of multi-programming, we can compare the degree of the programming with their high level. And next, lack of frames. In the previous page replacement algorithms, we have seen we can take a number of frames to replace our pages with newly arriving page. And next, page replacement policy based on this FIFO, LRU and optimal. This replacement policy may be considered based on the page replacement algorithm. Next, thrashing causes. Thrashing has an impact on the operating system of their execution performance. In this operating system, it consists their execution performance. Thrashing also causes serious performance issues with the operating system. So thrashes also contains some serious performance issues with the operating system. Why? Because whenever the page replacements or pages which are occurring frequently, they cannot execute properly. So in that case, the performance issues arises by the operating system. When the CPU's usage is low, the process scheduling mechanism tries to load multiple processes into the memory at the same time. So here the process scheduling mechanism tries to load multiple processes into the memory and in the same time, whereas it can increase their degree of multiprogramming. These are the causes of thrashing. So in this case, the number of processes in the memory exceeds the number of frames available in the memory. each process is set into frames to work on it. So for n number of pages, we are having some 3 frames, 4 frames to based on that frames, we are going to work on it for the replacing of the pages. If a high priority process arrives in memory and the frame is not vacant at the moment, the other process occupying the frame will be moved into the secondary storage. So here the frame which is arriving and it is not vacant, so the memory is full or the frame is full, then it is not vacant at the moment, then the process occupies the frames which are removed by the secondary storage, and the free frame will be allotted at the high priority process, and the free frame will be allocated with the high priority process. We may also argue that as soon as the memory is full, when they may argue when the memory is full, the procedure begins to take a long time to swap in required pages. So until now we have seen the pages which are full, we are going to swap which first in first out, and whether it is least recently or it is optimal. So based on the pages, we are going to swap the required page for the page replacement algorithm. Because most of the processes are waiting for pages, the CPU utilization drops again. So most of the pages will be waiting. So until and unless the page which is replaced with another page only, then only the waiting pages can be inserted, or else that cannot be inserted. This is what the CPU utilization drops down. As a result, a high level of multiprogramming and lack of frames are two of the most common reasons of crashing in the operating system. So as a result, which is at high level of programming, the lack of frames are divided into two most common reasons. That is what in crashing in the operating system. So here the CPU utilization and degree of multiprogram. So here the thrashing is causing at high level of degree of multi-programming. So this is what about causes of this thrashing caused by this page replacement algorithms. So in this we have discussed about page replacement algorithms. FIFO, LRU, optimal. And also we have discussed about thrashing, how the thrashing causes high level of degree of multiprogramming, and what are the page replacement policy, and what do you mean by page replacement algorithms. So if you have any doubts, you can comment in comment box. Thank you.